Okay, so these are some high school radical problems dealing with square roots, referred to them as radicals or square roots, or I think radical is a better term because it refers to the problems that deals with different roots of numbers. So the most familiar, I think, is square roots. Square root of 16, that's 4. And the idea is that 4 times 4 gives you 16. We build on this idea and we take the square root of 121. Again, this is another perfect, because it's another perfect square, 11, because 11 times 11 is 21. And then we could also say that each of these are equal to positive or negative 4, because negative 4 times negative 4 is also positive 16. And this could be written as positive or negative 11, because both positive or negative 11 times themselves gives you positive 121. Remember, a negative times a negative is a positive. So then we get a question like this, which says, what about the negative square root of 144? Well, this is going to be equal to, if we look at this right here, just the square root, that's positive or negative 12. And that's being multiplied by a negative number. So what does that mean? Well, in the first case, it's negative, right, times positive 12, which is negative 12. Or it's a negative times a negative, which is positive 12, so it could be either or still, even if with that negative sign out there. Now, if they're just looking for the positive root, and they'll usually specify, we could look at it a different way and say, well, the negative square root of 144. Sometimes we're only looking for the positive root of a number. If that's the case, we say, well, what's the positive root of 144? Well, that's 12. And then we still haven't dealt with this negative sign out there, so that would be a negative 12. But if we're not specifying if it's a positive or negative root, this negative sign, in fact, doesn't even change the answer, which is kind of cool. I don't think I've thought about that before. Here in this question we have, positive or negative square root of 100. Now this is what you'll usually see. You'll see that there's a positive or negative sign outside the radical. This is the radical, sorry, that's the radical symbol. And in fact, that is usually the indication that they want both the positive and negative root. And that means we can get positive 10, because 10 times 10 is 100, or negative 10, and this is how we write that, positive or negative 10. Either case, negative 10 times negative 10 is also positive 100. So we got both roots right there. This is actually representing two numbers. And then you can get problems with fractions, and the interesting property of fractions, which I've gone over in other videos, which is the square root of a fraction, that's equal to the square root of the numerator divided by the square root of the denominator. This is always true. You can see it in really simple examples. If we look up here, let's say I had the square root of 25 over 36, and actually I'm thinking right now it's probably not such a good example, but anyway, that's going to be equal to the square root of 25 over the square root of 36, which is equal to 5 over 6. Now, if I'm trying to think of a good way to show this, if we had looked at this fraction as a whole, we could say what fraction times itself gives you 25 over 36, and that is 5/6, right? So whether we break it up to numerator and denominator and take the square root of both, or if we just take the square root of the whole fraction, we still get the same answer of 5/6. That's going to happen here as well. Square root of 1 is 1, or we don't know what we're looking for, it's positive or negative 1. And then the square root of 4 is positive or negative 2. Now, they didn't give us the sign here for positive or negative roots, but if we did look for both positive and negative roots, we get a couple of options. In the first one, I could have a positive and positive denominator. In the second one, I could have a negative and a negative denominator, which ends up still being 1/2. And the third option, I can have a negative numerator and a positive denominator, which is negative 1/2. As the fourth option, we could have a positive numerator and a negative denominator, which is still negative 1/2. And what ends up happening, I think you see there really are still just two types of options. You have negative 1/2 and positive 1/2. But it is fun to see the different combinations and how it plays out with the number. And we can keep going with this type of example with fractions. So if I had the positive or negative square root of 25 over 81. Again, we can think of this as the positive or negative square root of 25, and this time we're going to isolate these two and just deal with the root first, over the square root of 81. That's going to equal 5 over 9, because the square root of 25 is 5, the square root of 81 is 9, and we're looking for the positive or negative, 5/9. So either case, that will be the square root. Working in reverse, if we take positive or negative 12 over 13 and square it, we can write that as equal to the square root of 144 over 169. Just thinking about it in the reverse, we can square both numerator and denominator, and that will give us a positive, right, 144, square root of 144 over 169. And actually, let me go back to this one, I'm sorry. I'm trying to think, if we have negative, no, this is right, I'm sorry. If we have positive or negative out here, right, the square root of 25 could still be positive or negative, and the square root of 81 could be positive or negative. So I'm trying to think of all these combinations, right, and this right here could be equal to 5/9 or negative 5/9, as we said in the last example. And then here there are two combinations, so but either way we're still combining positives and negatives, and in the end we'll end up with a positive or negative 5/9. So I'm trying to think of this answer right here, because what's interesting is if you square either positive 12/13 or negative 12/13, you have to get a positive 144 over 169. But you could also say that if I took the negative square root of this number, I can get back to 12 over 13, which is cool because in fact you can't take a negative fraction to get a negative result, but you can still make that cool connection with square roots, and I'll leave you to think about why that's happening. As a couple of other examples as I finish up, let's look at just the negative root. Sometimes you'll see this, just the negative root of 1.44. At first glance this might seem like a headache, but remember 12 times 12 is 144. So I use this to think about 1.44, and I think, well, if I took 1.2 times 12, what would happen to this number? Well, 1.2 is equal to, over here, 12 divided by 10. So it's 10 times smaller. This is 10 times smaller than 12. So if 12 times 12 is 144, then a number like 1.2 times 12 is going to be 14.4, right? Because it's 10 times smaller altogether. And then, if I'm doing this, I'm doing the square roots, the numbers have to be the same. This 12 also becomes 1.2, and again the product becomes 10 times smaller, and we get 1.44. So what does that mean? It means the square root of 1.44 is 1.2, and here we're just looking for the negative root, so that's negative 1.2. And we can keep going with this type of a strategy. Next we have the negative root of 0.01. Well, again, I know 10 times 10 is 100. So if I do 10 times 1, I get 10. I move the decimal point once this way. If I do 1 times 1, I move it again, right? And I'm going to keep going with this. 0.1 times 0.1 will move the decimal point 2 more times to the left and give me 0.01. I'm just following this pattern right here. So that means that the square root of 0.01 is equal to 0.1, because 0.1 times 0.1 is 0.01. And here we want the negative root, so we have the answer of negative 0.1. But again, like I said earlier in the video, I mean, roots can deal with any number. We can say, what about the cubic root of a number like 1? So what number times itself 3 times gives you 1, and that's still just 1. Typically, I think the first cube root I think of is the cube root of 8, which is 2, because 2 times 2 times 2 does give you 8. And we could ask all kinds of roots. What the fifth root of 32? That means what number times itself 5 times gives you 32, and the answer is 2. And what if we had as our last example? What if I had the negative cubed root of 125? Of negative, sorry, 125. Well, you might recognize right away that 5 times 5 times 5 gives me 125. So if the question was, what's the cubed root of 125, you would get 5. Here, we want to know what is the cubed root of negative 1, the negative cubed root of negative 125. What does that mean? Well, interestingly enough, if you take negative 5, right, times negative 5 times negative 5, every pair of negative numbers is a positive product. So this positive product times this negative number gives you a negative. So this is negative 125. So unlike squaring a number where you're looking at a positive result, when you cube a number, you can cube a negative number and still get a negative result. So that means the cubed root of negative 125 equals negative 5. But they don't want that. They want the negative root, negative cubic root of negative 125. Well, actually, I guess that means they do want negative 5, because that is the negative root. And what's interesting is now I'm wondering, I'm going to explore this a little bit more, does that mean for this number, the cubed root of negative 125, there's no positive root? Is there no positive way to get there? I'm used to thinking about taking, for example, the square root of negative 4, where that has no positive or negative answer. It leads us to deal with numbers like I. But I haven't thought about this situation where a negative number doesn't have a positive root. It only has a negative root. That's pretty cool. Alright, well, I hope you enjoyed this. Thanks.